Hi, in this lecture I am going to talk about Cramer's rule. But before going to the Cramer's rule, let me give you a review about the determinant in linear algebra. Let me write first, determinant, yeah, in linear algebra. Review. Determinant and linear algebra. Okay. The determinant in linear algebra must be a square matrix. Must be a square matrix. Remember, square matrix like this one, M2 times real numbers, or real numbers in this case, yeah, all real numbers, which is equivalent to real number 2 by 2, which is equivalent real number 2 by 2, the same form, yeah. This is the square matrix. Square matrix. And means n by n. Square matrix means n by n. Number of rows equal to what? Numbers of columns. Like this one. Means 2 by 2, 3 by 3, 4 by 4, like this one. Yeah. Okay. Okay, now let A belongs to M2. M means, M in this example mean matrix from this form, yeah. Okay, matrix, square matrix, 2, yeah, 2 by 2 means, yeah, times all real numbers. Hence A, the matrix A equal to A11, A12, A21 and A22. What are the meanings of this A11, A12, A21 and A22? First, let me start with the A11. Means A11 means the element in the first row, as we can see, and the first what? Column, and first column. And this one, the element A12, the element in what? First row. This is second column. First column, second column, yeah. This means the element in the first row and what? Second column. And this one, the element A21 is the element in the second row, and what? In the first row and the first column, yeah. And this one, element in the second row and second column also, yeah. Okay, let me now find the determinant of this matrix. If this is square matrix, now we can find the determinant. Determinant of A equal, which is the determinant of A, or determinant can be written as absolute of A. This is the same. Can be written in any one of these two forms, yeah. Which is equivalent. Now we can find the determinant of A or absolute of A, yeah. Which is the determinant of A equal to what? A 1 1, A 2 2, like this one. We multiply. We use another color. We multiply this one, A11 times A22, and we subtract. Then we subtract A12 times A21. First of all, we multiply A11 by A22, then we subtract A12 times A21, yeah. This is, and we subtract. This is, we can write A11, A22 minus, or subtraction of A12 times A21, like this. And all of this is belonging to the real numbers, or real numbers, or real numbers. Remember that. Okay. Let me give you an example. Example 1. Example 1. Find the determinant. Find the determinant of A. The determinant of a matrix. If A belongs to M2 R, which is equal the same of R2 by 2, which is equal to R2 by 2, means what? This form mean square matrix. Okay. We can find the determinant if the matrix is square. Yeah. If we have a square matrix, yeah. It's a square matrix. A is equal to what? 3. Let me use, okay, 3, 2, 5, and 7, yeah. Okay. Find the determinant. Determinant of A. Solution. Oh, let me use another color. Okay, solution. Okay. This is what? Square matrix, 2 by 2. Then, if it is square matrix, then we can find the determinant of A. As mentioned the question. Then determinant of A is equivalent to the absolute of A, which is equal to what? This one. Multiply this one by this one, then subtract this one times this one. 3 times 7 minus what? 2 times 5. 2 times 5, which is the same as A1. This is A11, A12, A21, A22. Yeah. Then this is 21 minus 10, which is 11. This is the determinant of A. Let me give you another example. Let me use another color for this example. Okay. Oops, not this one. Okay. Example 2. if A belongs to the M3, this means 3 by 3 matrix, which is square matrix also, times real number, which is equivalent real number 3 by 3, which is equivalent real number 3 by 3 also, and A is as follows. Okay, 1 0 2 3 1 minus 1 1 2 4. Find determinant of A. Okay, if you look at this matrix, 3 by 3 matrix, this 3 by 3 matrix, we cannot use the previous method, A12 times A22 minus A12 times A21. The previous method, this method, yeah, the previous method for only 2 by 2 matrix. For higher matrix like this one, 3 by 3, 4 by 3, 5 by 3, we have to use 2 steps. Okay, solution. Before giving you a solution, let me explain the steps for finding the determinant of this type 3 by 3 square matrix. Yeah, steps. We use another color. Okay. 1. We select any row or any column. I recommend you to use the one that has more zeros. Recommended the one that has more zeros. The second step, in this we have more zeros. You can select this row, even you can select this column, because it consists of 1 0. If you have, for example, 0 1 0, we use the one with more zeros. Yeah, in this case I prefer to use the first column, the second column. Yeah, this column, second column, instead of the first row. I will try. Therefore we selected the second column. In this case, this one. Let me highlight it. This one. This one, yeah. And you can use this row if you want. Yeah, you want to select the second column. Let me solve this example. Solution. Okay, let me use another color for that. Okay, this one. This is nice. Yeah. Okay. Determinant of A. Let me write the question before we want. Okay, let me write the question. This A is, the matrix A is 1 0 2 3 1 minus 1 and 1 2 4. We selected this column. 0 is 1, A2, A1 2, yeah, and this is 1 is the element 2 2, A22 and this one is A32. Remember this, yeah, these ones. Determinant equal to what? To the minus 1 1 plus 2 1 plus 2 this one 1 plus 2 take it as a rule minus 1 to the power 1 plus 2 times we multiply by a to the 1 2 this element I mean 0 times the determinant of this case if you A12 okay this is fixed and ignore this row in the first element and move to this one. This is the determinant of this one 3 minus 1 and 1 4 and plus minus 1 to the power what? 2 plus 2 2 plus 2 times A2 by 2 this element I mean 1 times the determinant